All right, so this is going to be the answer key for the test review. It says to simplify, leave no negative exponents, assume that no variable equals to 0. All right, so for this first one here, first thing I notice is that we have a negative sign, okay? So because there's a negative sign there, what I'm going to do is I'm going to move the top to the bottom, and then I'm going to move the bottom to the top of this fraction, because that will remove the negative sign. So when I rewrite this, it's going to be 3ab to the 7th on the top, divided by 5a to the 4th b to the 3rd on the bottom. And then now that negative 2 will become a positive 2. All right, the next thing I'm going to do is I'm going to simplify inside the parentheses. So 3 over 5 cannot reduce, so that stays 3/5. Now, when we are dividing like bases, we subtract the exponent. So this a has an exponent of 1. So 1 minus 4 is negative 3, and I'm going to place that at the top. For b, it's b and 7 and 3, so 7 minus 3 is 4, so b to the 4th on the top, and keep it squared. Now for the next part, any negative exponents I have, I'm going to remove them to the bottom. So for this case, I have a to the negative 3, so when I rewrite this, it's going to be 3b to the 4th on the top over 5a to the 3rd on the bottom, because that negative exponent, and then we square it. And then last, all I'm going to do is square each one. So the 3 has a power of 1, and so does the 5. So 1 times 2 is 2, so 3 squared is 9. 4 times 2 is 8. And then 1 times 2 is 2, so 5 squared is 25. And 3 times 2 is 6, so a to the 6th. And this will be my answer for number 1. All right, for number 2, we're going to distribute the exponent. So 3 times negative 3 is negative 9. 3 times 1 is 3 cubed. And 7 times 3 is 21. So from here, notice this has a negative exponent, so we move this to the bottom. 3 cubed is 27. A to the 21st. And then we said b to the negative 9th. We move this to the bottom to make the exponent positive. And since there's nothing remaining on the top, we're going to put a 1 there. And there's my answer for number 2. All right, for number 3, we're just going to distribute that exponent. So negative 5 has a power of 1, a has a power of 7, and b has a power of 6. So 1 times 2 is going to be negative 5 squared. 2 times 7 is a to the 14th. 2 times 6 is b to the 12th. And then negative 5 squared is 25. A to the 14th, b to the 12th. For number 4, we're just going to multiply. So coefficients, 4 times 2 is 8. A to the negative 6 times a squared. So when you're multiplying bases, you add the exponent. So negative 6 plus 2 is negative 4. B cubed times b to the 5th. So 3 plus 5 is 8. And then last, this has a negative exponent. So fraction bar. 8 has a positive exponent. B to the 8th has a positive exponent, and a to the negative 4th power moves to the bottom, making the exponent positive. All right, on to number 5. So we're going to reduce it. 4 divided by 2 is 2. A cubed over a squared, so we subtract. 3 minus 2 is 1, so that's a to the 1st. And for the b's, 6 minus 12 is negative 6. And last, we're going to make a fraction because this will have to move to the bottom. And the 2a stays at the top because they have positive exponents. All right, on to number 6. So again, we're going to reduce. 3 over 9 is 1/3. For the exponents, we subtract. Negative 8 minus 4 is negative 12. And for the b's, 6 minus 3 is 3. And we do have a negative exponent here. So the only thing that's left on top is b to the 3rd. You can add the 1 if you want. I don't think it's necessary, so I'm not going to. A to the negative 12th will move to the bottom with the 3, and notice the exponent does become positive. For number 7, anything raised to the 0 power is automatically 1. And last, we have number 8 here. So negative 4xy squared times 2xy. So we're going to distribute it to all terms here. So negative 4 times 2 is negative 8. X times x is 1 plus 1, which is x squared. Y squared times y to the 1st, so 2 plus 1 is 3. Now we distribute it to the next term. Negative 4 times 8 is minus 32. x times x to the fifth is x to the sixth, y squared. And then negative 4 times 7 is negative 28, xy squared. All right, on to number 9. So number 9 is telling me to add them together. There's a plus sign, so it's not necessary for these parentheses, so I'm not going to worry about them. So we're going to combine like terms. 5a squared plus 9a squared is 14a squared. Negative 4a minus 3a is negative 7a. And 7 minus 6 is 1. All right, for the next question. This one is a subtraction. So the first thing I'm going to do is I'm going to drop the parentheses on the first one because there's nothing to distribute or there's nothing to change. On the second one, this negative, I'm going to distribute it across, so it flips the sign. So that becomes negative 7r squared minus 6r minus 8. Now we combine like terms, so 8r squared minus 7r squared is 1r squared. 5r minus 6r is negative r. And then 14 minus 8 is positive 6. All right, now we're moving on to the next ones where we're multiplying it. So for this one here, we want to, when it's squared, we're going to write it out twice. So 2p plus q to the third times 2p plus q to the third. So we're going to FOIL this out. 2p times 2p is 4p squared. 2p times q to the third is plus 2p q to the third. Now q to the third times 2p is also 2p q to the third. And then last we have q to the third times q to the third, so we add the exponents, it becomes q to the sixth power. Now we're just going to combine our like terms. These are the only two we can combine. So this is going to be 4p squared plus 4p q to the third plus q to the sixth. All right, for number 12, we're going to double distribute. So we're going to start with distributing the x. So x times x squared is x to the third. X times 3x is 3x squared. X times 2 is 2x. 3 times x squared is positive 3x squared. So now I'm distributing the 3, the second term, to the parentheses. 3 times 3x is 9x, and 3 times 2 is 6. So now we combine our like terms. X cubed plus 6x squared plus 11x plus 6. All right, on to the next one. Find the perimeter and area of the rectangle. So for this one here, to find the perimeter, we just add up all the sides, so we know the ones across from each other are the same. So 2a minus 3, so this must be 2a minus 3. This is 5a minus 4, so this is also going to be 5a minus 4. So now we're going to add up the sides. 5a plus 5a plus 2a plus 2a is 14a. Negative 4 minus 3 minus 4 minus 3 is going to be minus 14. Now, for the area, we're going to do length times width. So 2a minus 3 times 5a minus 4. So 2a times 5a is 10a squared. 2a times negative 4 is negative 8a. Now we're going to distribute the negative 3. Negative 3 times 5a is negative 15a. And negative 3 times negative 4 is positive 12. The only terms we can combine are negative 8a and negative 15a. So 10a squared minus 23a when you combine those two, plus 12. All right, for number 14, here it says to find the area of the shaded region. So first we're going to find the area of the whole rectangle, which is 8x plus 6 times 6x. And we're going to subtract the area of the unshaded region, which is 2x times 2x plus 3. Now I'm going to distribute my 6x. So 6x times 8x is 48x squared. 6x times 6 is 36x. Negative 2x times 2x is minus 4x squared. Negative 2x times 3 is negative 6x. Now when we go to combine, we see 48x squared minus 4x squared is 44x squared. 36x minus 6x is a positive 30x. All right, on to the next problems. So for this one here, we're going to use divide. We're going to use long and synthetic division. So for this first one here, we're dividing by m plus 7, which is a linear binomial. So I could take this and set it equal to 0, and m would equal negative 7. So that's going to be my pivot point. Over here, I have m squared, m, and a constant. So m squared has a coefficient of 1, m has a coefficient of 13, and then we have a constant of 42. And then we apply synthetic division. So we drop the 1, then we multiply the pivot point times the number 1. So negative 7 times 1 is negative 7, and we put it under the next term. 13 minus 7 is 6. Now we multiply the pivot point times that 6, which is negative 42, and we place that underneath the next term. So 42 minus 42 is 0. So since we started with m squared, we drop 1 power, which would be m to the first. So this is going to be m and my constant. So m plus 6 is my solution. Since my remainder is 0, I do not have to write it out, because it's 0 divided by anything is going to be 0. Okay, now number 16, be careful, because it does need to be in standard form, right? So if you take a look here, this is not in standard form. So this should actually be 5x cubed plus 6x squared plus 9 is divided by x plus 3. Now, we're going to take x plus 3, set that equal to 0, and solve, and we get negative 3. So my pivot point is negative 3. Over here, we have x cubed, x squared, but no x. So 5, 6, 0, and 9. So x cubed, x squared, x constant. And we just go through that process of synthetic division. So we're going to drop the 5. Pivot point times 5, so negative 3 times 5 is negative 15. 6 minus 15 is going to be negative 9. Then we multiply the pivot point times negative 9, that's going to be positive 27. Combine 0 plus 27 is 27. And then negative 3 times 27 is going to be, let's see, 25, 50, 75, 1, 2, 3, 81. And then we have 9 minus 81, which is going to be negative 72. So since this was x cubed, this will be x squared. So my answer would be 5x squared minus 9x plus 27 plus my remainder over my divisor. All right, now we have this next problem here. This one is going to be a little bit longer. It is long division. So we first look at the divisor and notice there's no missing powers. X squared 2x minus 4. And for my dividend, x to the fourth, x cubed, x squared. There is no x, so I put a 0 in its spot, minus 39. All right, so from here, we're going to take the leading terms and divide them. So the leading term of the dividend is 5x to the fourth, divided by the leading term of the divisor, which is x squared. So we have 5x to the fourth divided by x squared, which is going to be 5x squared. Then we multiply this to the divisor. So 5x squared times x squared is 5x to the fourth. 5x squared times 2x is 10x to the third. 5x squared times negative 4 is minus 20x squared. Now we're going to subtract, and that tells us to flip the sign, so positive, negative, negative, positive. When we combine 5x to the fourth minus 5x to the fourth is 0. Negative 2x cubed minus 10x cubed is going to be negative 12x cubed. Negative 7x squared plus 20x squared is going to be 13x squared. And then we bring down our next term. And then we repeat the process. So I'm going to use my leading term now is negative 12x cubed. And we're going to divide that by x squared. And that's going to give me negative 12x. And then multiply that to the divisor. So negative 12x times x squared is negative 12x to the third. Negative 12x times 2 is negative 24x squared. Negative 12x times negative 4 is 48x. We are now going to subtract that, which we flip the sign, so plus, 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 minus. So negative 12x cubed plus 12x cubed is 0. 13x squared plus 24x squared is 37x squared. 0 minus 48x is negative 48x, and then we bring down our next number, which is minus 39. Our next term, sorry. So now we take 37x squared, our leading term, and divide it by x squared. And that gives us positive 37. All right, now we multiply. 37 times x squared is 37x squared. 37 times 2x is going to be 74x. And 37 times 4 is going to be negative 148. And now we're going to subtract. So flip the signs. And 37x squared minus 37x squared is 0. Negative 48x minus 74x is negative 122x. Negative 39 plus 148 is going to be positive 109. And this is my remainder because the exponent here is 1, which is smaller than the exponent here, which is a 2. So my final answer is going to be my quotient, 5x squared minus 12x plus 37, plus my remainder over my divisor, which is x squared plus 2x minus 4. So pretty lengthy process, but there is your answer. All right, let's go ahead and take a look at these 19 through 21 here. And I know there's a number 30 here, but we'll talk about that one. So decide whether the function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. So remember, to be a polynomial, the exponent has to be whole numbers. Now remember, whole numbers are 0 to positive infinity, okay? Not a polynomial, negative exponents, negative exponents, fraction exponents, fraction exponents, variables as exponents, and variables in the denominator of a fraction, right? Okay, so that's that there. I know I took up a little bit of room, but let's go ahead and do this. All right, so the first thing we're gonna do is we're gonna look at the exponents for each one. X cubed, x to the negative 3. I can stop right there. Since this has a negative exponent, it's not a polynomial function. And I don't have to fill out the rest because it's done. For number 20, x squared, constant x. So there are no negative exponents. It is a polynomial function. So we're going to write in standard form. So standard form is from least to greatest in terms of exponents. So x squared is 11x squared. We have positive 12x. And then we have minus the square root of 7. So that's in standard form. Now in terms of the degree, we look at this number, this exponent of 2, which is degree is 2. The type, since it's 2, that's a square, which is quadratic. And the leading coefficient is the number 11. All right, for my next one, again, we're going to look at the exponents. We have x to the 4th, x squared, x cubed, x, and a constant. So it is a polynomial function. So we're going to write it in standard form. So we have 2x to the 4th first. We have minus the square root of 14 x to the 3rd minus 1/3 x squared plus 2x minus 5/3. Now once we put it here, we know that our leading term will have degree and type and all that. So the degree is 4. The type, 4, is a quartic. And the leading coefficient is this value of 2 in the front. Okay, the next question says to evaluate the function given the value of x, and there are 2 ways to do this. One way you can do it is you just plug negative 11 in for x. So I'm not going to work it out this way, but I'm going to show you what you can do. And the second way is to do synthetic division. So negative 11. So we have x cubed, which has a negative 1. We have x squared, which has a positive 5. We have 9x, which is 9, and a 4 as a constant. So no missing powers, that's why there's not a 0. So we drop the negative 1. We multiply. Negative 11 times negative 1 is 11. 11 plus 5 is 16. Now these numbers appear to be getting big pretty quick here. So what I am going to do is I'm going to have to use a calculator so I don't make any small errors here. So negative 11 times 16 is going to be 176, and that'll be negative. And then we add 9 to that, and we get negative 167. Now negative 11 times 167 is going to be 1,837. And then we're going to combine these, so that's going to be 1841. and that is my remainder, so that is my solution. So f of negative 11 is equal to 1,841. And if you wanted to double check this, you could definitely do that in a calculator. All right, so this is how it would look. So I'm just going to type this in this calculator here real quick so you can kind of see. So if we did it like this one here, so negative 11 raised to the third plus 5 times the negative 11 squared plus 9 times negative 11 plus 4. Whoops. So let's try that one more time. Negative parentheses negative 11 cubed plus 5 times plus 9 times plus 4. I think I got that all right. 1841. And there you go. Okay. So you can definitely double check it that way. But those are the two ways you can work it out. All right. Now we're on to the last part here. It says in exercises 22 through 25, describe the end behavior of the graph of the function. So let's kind of go over this really quickly as a refresher. So when it asks for the degree, so the degree can be two things. The degree is either going to be even or it's going to be odd, okay? So when we talk about even, we're talking about the exponent being an even number, 2, 4, 6, 8, 10, and so on. But also when we're talking graphically what even looks like, that means they're going to have the same direction. Like the arrowheads, the end behaviors will be headed in the same direction. In terms of odd, they're mixed. One goes up, one goes down. But if we're talking about degree, it's an odd number, 1, 3, 5, 7, 9. When we talk about the leading coefficient, we're talking about it whether it's positive or it is negative. So in terms of positive, one on the right side is going to be going up, and the arrowhead on the right side will be going down if it's negative. Okay, and obviously the coefficient, if it's positive, it's positive. If it's negative, it's negative. So that's pretty straightforward. So let's go ahead and take a look at number 22. So the first thing is they may not be in standard form, so go through and make sure you do identify the highest degree, the highest power. So x to the fourth, x to the third, x squared, x, and a constant. So my highest power is 6x to the fourth. So the degree is 4, and that number is even. My leading number is 6, and that's positive. Now, if you recall, when it's even and positive, it kind of looks like it resembles a quadratic function, very similar to it. So as x approaches negative infinity, so let me show you. As x approaches negative infinity, the graph y approaches, well, this is going up towards positive infinity. And as x approaches positive infinity, the y value of this graph approaches positive infinity as well. Okay, so that rough sketch helps me to see that. All right, for number 23, again, negative 5x to the 9th, x to the 7th, x to the 4th, x squared minus 1. So once again, it is the leading term that is has the highest degree. So the highest degree here is 9, and that is an odd number. And the leading coefficient is negative 5, and that is a negative. So if I recall from what we know from past experience, that means it's sloping down like this. So as x approaches negative infinity, we can see that this approaches positive infinity. And as x approaches positive infinity, the graph is going down towards negative infinity. Okay, let's take a look at the next one, number 24. So negative 5x to the fourth, 7x cubed, minus 7x to the sixth, x squared, minus 9x2. So we can see here that this is my highest power. So again, the degree is 6, which is even. And the leading coefficient is negative 7, which is negative. So this time, it would be similar to a parabola facing down, okay? So once we have that there, as x approaches negative infinity, we can see this graph heads down towards negative infinity as well. And as x approaches positive infinity, we can see this graph also is heading down as well to negative infinity. And for the last one here, for 25, x cubed, x squared, x to the fifth, x to the fourth, x squared constant. So we can see this is our highest degree. So I'm not going to write the 5 anymore. I can see it's odd. And the leading coefficient is 4, which is positive. I can draw my shape. So from left to right, it's going up. So as x approaches negative infinity, we can see the graph is heading down towards negative infinity. And as x approaches positive infinity, we can see the graph is going up towards positive infinity. Okay. Now last, we have these two problems here. It says in exercise 26 and 27, describe the degree and leading coefficient of the polynomial function using the graph. Okay. So the first thing is, since they're both going in the same direction, if they're both going in the same direction, we know that degree is even. And if you look at the right side, this one is going up. So if it heads up on the right, then it's positive. And again, over here, they're mixed. So if they're mixed, it's odd. And since this one is going up to the right, it is positive. All right, and make sure you do look over your old notes and any assignments you may have that you want to look over for this test.